So we're going to look at a couple of square root problems where when we take the square root, there's no more root left. So something like square root of 25. So we're looking for what squared gets us 25, since square roots and squaring something are opposites. So if I think about what squared gets me 25, that is 5. So the square root of 25 is 5. Or the square root of 16 over 81. So we can kind of think of it just what's the square root of 16 on top? That's 4. What's the square root of 81 on the bottom? That's 9. Because 4 ninths squared, or 4 ninths times 4 ninths, would get us 16 over 81. Okay, or how about the square root of negative 9? So at this point, if we think about it, nothing squared gets us negative 9. So this is not a real number. So these are problems we've already done at this point, but now we're going to throw in something new. So that was just kind of some refresher problems. How about this one? So now we're going to be throwing in some x's. How about the square root of x squared? If we think about what times itself gets me x squared, that would be x. Because really, like any number, if I just replace this with, let's say 3 squared, well, that's square root of 9, which is 3. So it's kind of like the squared and the square root cancel each other out because they're opposite operations. Now, one thing, if we think about this a little more, what else squared that I take the square root of could get me something similar to 3? Or let's say, let's do this. Would that be negative 3? So if we work that out, the square root of negative 3 squared is 9. The square root of 9 is actually a positive 3 though. So what we have right here, that is not true. The square root of negative 3 squared is not necessarily negative 3. It actually becomes positive 3. So I'm going to add something to that square root of x squared that we just did. The square root of x squared is actually technically the absolute value of x, because whatever is in that spot of x, it would need to be positive to work out. Okay, so normally though, we were not going to worry too much about those absolute values. Like for example, let's say the square root of x to the 4th. Something like this, where we're not going to worry about the square root, but you're going to see that sometimes in answers, like if you're looking in the back of the book or seeing examples in your book. So how about the square root of x to the 4th? So if we think about it, comparing to the last ones, we were trying to figure out what squared gets us x to the 4th. So if we think about the power rule, the only way I'm going to get 4 there is if I have x squared. So x squared squared gets me x to the 4th. So then if I think of the square root and the squared like they're canceling, I'd be left with the x squared. Okay, or how about the square root of x to the 14th? Okay, so here if I'm trying to figure out what squared gets me x to the 14th, it would have to be x to the 7th in here, because x to the 7th squared is x to the 14th. So now square root, squared cancel, and I'm left with x to the 7th. So really, if you think about it, whatever the exponent on the inside is, we're cutting it in half. Like this one, 14 divided by 2, we're going to be left with x to the 7th. How about this one? Square root of 4x to the 22nd. So here we've got a coefficient and we have an x in the square root. So we can kind of just look at these one at a time. The square root of 4 is 2. The square root of x to the 22nd is x to the 11th. And then to see if that makes sense, 2x to the 11th squared, to kind of do this as a check, 2 squared is 4, and x to the 11th squared is to the 22nd. So that checks out. So there's my answer.